Welcome back to Think Thrice Problem Solving. Today we're going to be solving a fun geometric problem. So this problem is very similar to a previously done problem. We did a circle with the blue square and the red square below it, and we found that the area of the red over the area of blue for a circle was 1 over 25, which is a nice number. So what we're going to do now is we're going to do this for a general ellipse with the long and short axis given by B and A respectively. And the equation for our ellipse is going to be this guy down here. X over a squared plus y over b squared is equal to 1. And we're going to see if we can determine the area of the red over the area of the blue. And it's not quite as nice as it was before, but we can arrive at a solution. This was posed by one of our viewers, Mr. Sham. So we'll go ahead and work through this. So if you'd like to give it a try, go ahead and pause the video. Otherwise, we're going to go straight into a solution. So what we're going to do is we're going to look at this ellipse, and what we're going to note is first, I'd really love to know what this point is down here. Because if I know what point that is, then if I know where the x and y coordinates are, then that can kind of get me on my way to solving where my red square is. So what I'm going to do is I'm going to set up some axes here. So I'm going to set up my x-axis going over, and I'm actually going to set up my y-axis going down. And if I flip this, it's symmetric, so it'll work either way. And what I'm going to do here is I'm going to use a little bit of a substitution that might look weird at first. So what I'm going to do is I'm going to say x is equal to a times cosine of theta. So theta is not exactly the angle that we would use in polar coordinates here, but it represents a very similar thing. And y is going to be b sine of theta. So very similar to my polar coordinates that I might use if I was doing I guess that'd be multivariable integration. Okay, so what you're probably saying is, how do I know that'll work? So why am I sure that as I increase this parameter theta, I'm actually staying on my ellipse? So what I'm positing is that this theta acts as a parameter, and as I start at 0, so my 0 would be right here, and as I increase theta, I'm going to ride the edge of my ellipse right here. So that's what I'm saying will happen. And that'll happen if this equation over on the right is true. So let's go ahead and plug our values in and see if it's still true. So if I plug in a cosine of theta instead of x, divide that by a and square it, and then plug in b sine of theta divided by b, square it, then I notice that a few things cancel. So my b's cancel, my a's cancel, and I'm left with cosine squared of theta plus sine squared of theta is equal to, and what is that equal to? We know it's equal to 1 if we've done a little bit of trigonometry. And it's basically because of the Pythagorean theorem. So this is x over r squared plus y over r squared, which is equal to x squared plus y squared over r squared, which x squared plus y squared in a triangle is r squared, which is why that's equal to 1. Okay, so what I've just shown is that this is a valid substitution to use. And the theta is not exactly the angle off of my axis like it would be in polar, so it doesn't mean the exact same thing, but it is a parameter that will follow that curve. Okay, so what we're going to do is we're going to use that parameterization, and what I'm going to argue now is to find this point. Since this angle here is 45-degree angles, and this is a right triangle, I know at this point, since it's at a square, x is going to equal y. So I want to find my value of theta, which remember theta is not that angle 45, such that my x value is going to be equal to my y value. So let's go ahead and do that. So I'm going to set a cosine of theta equal to b sine of theta. That gives me a over b is equal to sine of theta divided by cosine theta, which is equal to tangent of theta. Okay, so theta is going to be equal to arctan of a over b. So now how do I get my x and y values? So my x and y values, I already said they're going to be the same. So y is going to be equal to x, which is then going to be a cosine of tangent -1 of a over b. And we're probably thinking, oh, we need to break out a calculator, but we can't because it's variable, so we're stuck. but we're actually not. So let's go ahead and look at this. So let's imagine the triangle that makes that true. So if I had a right triangle, and I had tangent as a over b, that means y over x would be a over b. So what would my hypotenuse be? So my hypotenuse would just be square root of a squared plus b squared. So if I wanted to find cosine of that triangle, what would my cosine be? Well, my cosine would just be b over square root of a squared plus b squared. So my y and x are actually now just going to be a times b divided by square root of a squared plus b squared, which is adjacent over hypotenuse. Or, yeah, adjacent over, sorry. So what we're going to get then is that those are equal to a times b divided by the square root of a squared plus b squared. All right, so this is point one that's pretty important. So we've just done is we've solved, and I now have an expression for the x and y coordinates here of this point in terms of just a and b, which that's what my problem is based on, so a and b. Okay, so now that I have that point, what I'd really like to do, so if I have that point, then I know this point right here. And what I notice is, if I label the side length here as s, then I'm adding s in the y direction, and I'm adding s over 2 in the x direction. So what I want to do now is I want to find what is the angle in my expression that goes to this point right here. So I'm going to have a new point of interest. So what I'm wanting to find here now is my x and y for that point. And at this point, x is not equal to y. I have one variable, s, that's going to be unknown. So I'm going to still be able to solve for that guy. So what are we going to look at here? So now I know let's rewrite my x and my y. So my x position is just going to be s over 2. So x equals a cosine of theta is going to be s over 2. So this is a new theta. So we're solving for a new theta here. And what's my y going to be? Well, my y is going to be the y that I just found plus s. So my y is going to be b sine of theta. And that's going to equal ab over the square root of a squared plus b squared plus s. Okay, so now we're going to use a similar solution technique as we did before. So with this first equation, I have theta is going to be equal to the inverse cosine of s over 2a. And then I can go down here and I see that b sine of the inverse cosine of s over 2a is going to be equal to ab over the square root of a squared plus b squared plus s. So what am I going to do here? Well, let's create a fun little triangle again. So let's look at this new triangle and solve for what our theta is going to be. So I have cosine is s over 2a. So what is my opposite going to be? Well, so that's going to be by Pythagorean theorem. It's going to be square root of 4a squared minus s squared. And that's going to be that side over there. So if I wanted to find sine of that triangle, so I'm looking for sine of this, sine of that angle is going to be the square root of 4a squared minus s squared divided by 2a. Okay. So we're making a little bit of headway here. So let's go ahead and rewrite my equation here and substitute in for sine of theta. So now I'm going to get b times the square root of 4a squared minus s squared divided by 2a is equal to ab over the square root of a squared plus b squared plus s. So what are we doing now? So really what we need to do is we need to solve for this s guy. So how are we going to do that? Well, in exactly the messy way that you might be thinking, let's square both sides. So if we square both sides, we're going to get b squared times 4a squared minus s squared divided by 4a squared is equal to, I'm going to get a squared b squared divided by a squared plus b squared plus 2 times sab divided by the square root of a squared plus b squared plus s squared. Okay, so we're going to have to kind of simplify this and rearrange a little bit. So let's go ahead and do that. So b squared times 4a squared over 4a squared is just going to be b squared. I'm going to have minus b squared s squared over 4a squared is equal to, this guy doesn't really do anything, so a squared b squared over a squared plus b squared is still the same. Then 2sab over square root of a squared plus b squared, and then plus s squared. So let's go ahead and combine like terms. So let's look at s squared. And I'm going to look at the right side of the equation as positive. So I'm going to have s squared times 1, and then we're going to move this over, so we'll have to add it, plus b squared over 4a squared, plus s, so that's this guy right here, times 2ab over the square root of a squared plus b squared. And then we're going to get plus, I have a squared b squared over a squared plus b squared minus b squared. And instead of minus b squared, I'm going to multiply this by a squared plus b squared. And what I notice then is that this guy is going to become b squared a squared plus b to the fourth. And I'm going to have a few things cancel. So this a squared b squared and this a squared b squared are going to cancel. And I'm going to be left with, at the end of the day, just b to the fourth over a squared plus b squared, and that's a minus, sorry. So this is going to be minus b to the fourth over a squared plus b squared, and that whole thing is going to be equal to 0. And hopefully somebody found a better way to do this, but I'm going to go ahead and do the wonderful quadratic formula on this guy. So let's go ahead and work that out. So s is going to be equal to negative b, so negative 2ab over square root of a squared plus b squared, plus or minus, so remember the s is a side length and this is already negative, so I better be adding something. So this is going to be plus the square root of b squared, which is 4a squared b squared divided by a squared plus b squared, minus 4ac, so minus 4 times 1 plus b squared over 4a squared, times c, which is negative, so I'm going to have a plus there, b to the fourth over a squared plus b squared. That whole thing is under the radical. And that's going to be divided by 2a, and my a in this case is 1 plus b squared over 4a squared, so I'm going to have 2 plus b squared over 2a squared. Okay, so I'm going to spend a minute or two trying to clean this up just a little bit so it's a little bit less disgusting. So we're going to have s is equal to, I can pull a 1 over square root of a squared plus b squared out of this guy. And I can also pull a 2 out. So I'm going to pull that 2 out. And what I'm going to be left with is negative ab. Sorry, and now that's, I'll leave that there. Yeah, so negative ab plus, I pulled a 2 out, so I need to pull a 4 out of the radical. And that a squared plus b squared in the denominator also came out. So I'm going to be left with a squared b squared plus 1 plus b squared over 4a squared times b to the fourth, and that was pulled out, so it's going to be times b to the fourth. So I can rewrite this now. Let's go ahead and just write that in as b to the fourth, and then this will be b to the sixth. Okay. Okay, let's see what we got here. So now that I have my expression in a little bit cleaner form here, let me double check something. Okay, yeah, I think that looks right. Hopefully nobody notices a mistake, but if you do, please let me know. I like to at least put a note in that I messed up, which I do because I'm human. So that's going to be divided by 2 plus b squared over 2a squared. Then what I can do is let's try to get this guy out of there and make this a little bit, we'll call it cleaner. It's just going to be different. We'll call it different. So s is going to be 2 over the square root of a squared plus b squared times, we'll multiply that 2a squared, so it's going to be negative 2a cubed b plus the square root, and now we have 2a squared going under the radical, so that's going to be 4a to the fourth. It's going to be 4a to the sixth b squared plus 4a to the fourth b to the fourth plus that 4a squared is going to cancel, and we're just going to have b to the sixth, and that's all over 4a squared now plus b squared. Okay, and that's as much as I'm going to try to clean this guy up. And for the rest of perpetuity, this is now going to be known as Bob of ab divided by the square root of a squared plus b squared. Okay, so what is Bob? Bob is all of this mess. That is Bob. So say hello to Bob. He's our new friend. And we're not going to write that all out anymore. So if I want to do my area, so remember what S was, if you can. So S is the side length of my small square. And I found that my X or Y I found before was 1/2 of my side length of my large square. So the red area is going to be S squared, which is going to be Bob squared divided by a squared plus b squared. My blue area was my 2 times my side length from earlier squared, and before I had, so this is going to be 2 times x, or not x, it was 1 second, so let's make sure we get that right. It was this guy right here, ab over square root of a squared plus b squared. So this is going to be ab over the square root of a squared plus b squared. And that whole thing is squared, which is going to give us 4a squared b squared divided by a squared plus b squared. Okay, so if I want to know red over blue is then going to be Bob squared. And notice the a squared plus b squareds are going to cancel, so it's going to be Bob squared divided by 4a squared b squared. Okay, so is that satisfying? Maybe not the most satisfying, but let's go ahead and check it out. So remember, Bob is this guy. So what we ended up with is a very nasty expression that perhaps we could take a little bit out of, but if we took the a squared out, there's stuff in the radical that wouldn't get simplified. So dealer's choice if you want to try to simplify this anymore. But let's check it. So at a equals b equals 1, so this would be with our circle that we had earlier, what do we get? So if we do that, we get Bob of 1, 1 is equal to 2 times negative 2 plus the square root of 4 plus 4 plus 1 divided by 4 plus 1. So Bob is going to be negative 2 plus 3, so 1 over 5, 2 over 5. So what I'm going to get here is then going to be 2 over 5 squared divided by 4 times 1 times 1, which is going to be 4 over 25 divided by 4. Thank the good Lord, we end up getting 1 over 25. So we got the exact same answer as we got the other day with our circle. The circle was much simpler calculation. But now, if we wanted to, for any eccentricity, for any A and B, we would be able to calculate that ratio between the areas. And unfortunately, it's not that pretty unless we choose very specific eccentricities like our little circle here. And that is going to be where I stop today. So I hope you enjoyed working through that problem with me. If you did, please like and subscribe. If you have an idea for a different problem, please submit it. And as you're working through problems, think once, think twice, and if you really, really get stuck, think thrice.